Today I'm going to cover, the Blazor part basically. So the topic name is Unleashing the Power of Blazor, the future of web development. That's what I feel. So as I mentioned earlier, this is Chandrasekhar. So currently working as a senior staff engineer for one of the biggest retail company. So you know, I'll start with the introduction of to Blazor basically. So Blazor is a .NET front-end framework that allows you to build applications using C Sharp and Razor components. So if you are familiar with the web development, we are hearing a lot of technologies like Angular, React, Vue.js, and different technologies. But with Blazor, we can develop the web application only with C Sharp and with the Razor components. And also we have the privilege, or we have the capability within the Blazor that we can interact with the JavaScript as well. So it's a powerful tool that enables you to create fast, interactive, and scalable web applications. So unlike other JavaScript based frameworks, Blazor allows you to write rich web applications entirely in C Sharp, eliminating the need to switch between the languages for back-end and front-end development. So we can develop the scalable applications, the web applications basically entirely in C Sharp. It combines the power of .NET with the simplicity of modern web development without relying on the JavaScript. So that is the biggest advantage of Blazor. And also, it simplifies the full stack development for .NET developers by allowing code sharing between the client and server. So it was introduced in 2017 by Steve Sanderson at Oslo. It leverages basically, the WebAssembly for client-side execution. So the Blazor, the name, the history behind it is a mix of browser and Razor. So reflecting its ability to run C# code in the browser, replacing the traditional server-side rendering within client-side approach. So this is all about the introduction to Blazor. So I would like to give a deep dive into the Blazor. Uh, I would like to start with the key features of Blazor. So Blazor supports, or Blazor is a component-based architecture. So we can build the reusable UI components with C Sharp, HTML, and CSS like we do in Angular or React. We'll have the same sort of thing, like we can build the components. It supports two hosting models. I said two, but I mentioned three. I'll give you the history as well. Till .NET 6 or 7, we have a Blazor server and the Blazor WebAssembly. But in .NET 8 onwards, we are having the Blazor WebAssembly and Blazor hybrid. So the Blazor server is basically, it supports server-side rendering with real-time updates via Signaler. Whereas the Blazor WebAssembly is the client-side rendering. So typically it works as in WebAssembly rendering, like the code whatever is compiled will be downloaded to the browser side, and from there it will operate. Whereas Blazor hybrid from .NET 8 onwards, it will have it targets basically the web desktop, the Maui basically I'm talking about. So as I mentioned, the Blazor supports the web development as well as the desktop development and mobile development, and also it supports the JavaScript interoperability, meaning that it integrates with the existing JavaScript libraries, as well as from JavaScript we can able to call the C# code as well. So when we are looking back into the history, like when we have ASP.NET, ASP.NET MVC, whatever we develop, somehow we rely on the JavaScript. Here also, it supports the same sort of thing, but it's more into Razor and more into the C# kind of thing. So these are the key features of Blazor. Uh, so I would like to elaborate more on the component based architecture. So Blazor apps are based on the components. So a component in Blazor is an element of UI. Say for example, the button is a component. So any element of UI is a component, such as a page or a dialog or a data entry form. You know, whatever, we'll call it as a component. Components are .NET C# classes built into .NET assemblies, basically. So it defines the flexible UI rendering logic, handle user events, can be nested and reused. So the main purpose is, you know, reusability. So it increases the reusability if we create the components in an appropriate way. And also the component class is as usually written in the form of Razor markup language with .razor file extension. Razor is a syntax for combining HTML markup with C# code and designed for developer productivity. So see here, on the right hand side, I mentioned, the code basically, at the rate code, and then we are writing the methods that can be invoked. See here, the increment count is a method that is being used at on click. So, this method is being called here. So the components render into an in-memory representation of the browser's documentation, that is DOM basically, called render a tree, which is used to update the UI in flexible and efficient way. Okay, so this is all about the component based architecture. So now I would like to go into the hosting models. So as I mentioned, one of the hosting model is Blazor server. So it supports hosting of the Razor components on the server in an ASP.NET Core environment. So assume that this is the server, and we have the ASP.NET Core here, and resides that we'll have the Razor components. So these Razor components basically will be rendered as in DOM, but the interactivity will be happen through Signaler. So here I'll go into deep. So the UI updates and event handling and the JS calls are handled over Signaler connection using the WebSocket protocol. So in a way, it's a blessing because the end user doesn't know that something is happening, so it will give an single page application uh, kind of feel to the end user, but internally it uses Signaler and it will communicate through WebSockets protocol. The runtime stays on the server side and executes the application C# code and sending the UI events from the browser to the server, and also applying back the UI updates to render the component that are sent back by the server. So the changes will be applied on the DOM side, but the communication will be happened through Signaler in Blazor server hosting model. So when a Razor page or a view is rendered to the browser, every line of Razor code emits the HTML in text format, so that it will be rendered. The HTML will be rendered on the DOM side or the browser side. The Blazor produces a graph of the components. So all the components that are rendered as an HTML will be rendered as a graph of the components to display on to display basically similar to HTML or the XML term. A component is disposed after the user navigates to another page. So to get the memory optimization, so whenever we are navigating from one component to another component, the it will dispose that particular component which is being rendered. So after the UI components are interactive on the UI, and the UI updates are triggered by the user interactions and the app events. When an update occurs, the component graph is rendered. I already mentioned, and also the Signaler. Basically, everybody knows about the Signaler, but to be on the point here, on this context, Signaler is a powerful library developed by Microsoft, and that seamlessly incorporate real-time functionality into applications. So it allows you to push content from the server to connected clients in the real time. So that's how the Signaler works. So now I'm going to Blazor WebAssembly. So the Blazor WebAssembly is completely a different approach from the Blazor. So Blazor WebAssembly is a single-page application framework for building the interactive client-side web apps with .NET. And running .NET code inside the browser is made possible by WebAssembly. As I mentioned, so whenever in WebAssembly project is application is built and run, four things will happen. The C# code files and the Razor files are compiled into .NET assemblies, and those assemblies will be downloaded to the browser. And Blazor the Blazor WebAssembly bootstrap the .NET WebAssembly runtime and configures the runtime to load the assemblies for the application. So everything will be bootstrapped and downloaded to the browser. The runtime uses, so here it is not like Blazor server app, but here the way it works is the runtime uses the JavaScript interop to handle the DOM manipulations and browser API calls. And Blazor WebAssembly optimizes the payload size to reduce the download times. So if you are building an very big application, the download time will be huge. So to reduce that, basically what they are doing is unused code is stripped out of the app when it is published by the IL trimmer, and HTTP response are compressed. The .NET runtime and assemblies are cached in the browser. So this is how on a high level it's all about the Blazor WebAssembly. So I think I'm good. So any questions for me? Okay, fine. So now I'm going to the Blazor hybrid. So it is from .NET 8. This functionality, or this one is coming from the .NET 8. So Blazor hybrid enables using the Razor components in a native client app with a blend of native and web technologies for the web, mobile, and desktop platform. So basically, the code runs natively in the .NET process and renders the web UI to an embedded web view control. So WebAssembly isn't used in hybrid apps, but it uses, the hybrid apps are built with .NET MAUI, which is a cross-platform framework for creating native mobile and desktop apps with C# and XAML. So Blazor Hybrid supports WPF and Windows Forms to transition applications from earlier technology to .NET MAUI. So it particularly well suited for the building the applications that needed to run both desktop mobile platforms. So this is all about Blazor Hybrid. So I'll talk about benefits, limitations, and challenges, but I'll come to this slide later point of time. But I would like to cover the reasons to adopt Blazor. Okay, so the Blazor offers unified development language. So Blazor allows you to use C# for both front-end and back-end development, reducing the need to switch between the languages. So Angular, React primarily uses JavaScript, TypeScript, which might require additional learning for a .NET developer. But if you are developing the application using Blazor, you doesn't need to. You can develop the web application with the help of C#. And also, it offers seamless integration with .NET. Blazor integrates, deeply with the .NET ecosystem, making it easier to use existing libraries and tools. This can be streamlined development process for teams already using .NET technology. So it offers seamless integration with the .NET, and also it offers component reusability. So Blazor components can be reused across different platforms, including web, mobile, and desktop applications through .NET MAUI. And also, the Angular and React. When it comes to Angular and React, it also supports the component-based architecture, but may require different frameworks for mobile and desktop. But if you are developing an application targeting cross platforms, with the help of .NET MAUI, we can develop the applications to support the cross platforms. And when it comes to the performance improvements, like the Blazor WebAssembly has significant performance enhancements with the .NET 8. I see as an I'm past 2 years or 3 years I'm working on Blazor. So with .NET 8, I'm seeing a lot of enhancements. Uh, so including the reduced app sizes and faster load times. Angular and React have their own performance optimizations, but may not benefit from the same level of integration with .NET. So these are the four reasons I mentioned as the main reasons to adopt the Blazor. So when to adopt the Blazor? So we have Angular, we have React, and we have legacy applications. So it is very important to know when to adopt the Blazor. So if you are having an existing .NET infrastructure, then it is better to adopt Blazor to modernize your application. So if your organization has an already has a significant investment in .NET technologies, adopting Blazor can leverage existing skills and infrastructure. So and also the full stack development, as I mentioned, through C Sharp, uh, we can develop both front end as well as the back end code. And also, this is also I mentioned, like the cross-platform application support with the .NET MOVI. We can able to develop the cross-platform applications and also the real-time applications. So if you are looking into the Blazor server, it communicates from client to server using Signaler, right? So it is well suited for the real-time applications where server-side rendering and the constant server connections are beneficial. So and the long-term project. So if you are going with Angular or React or any other open sources, like will the maintenance will be heavy because we may develop using few libraries. Those will be obsoleted at one point of time, and yeah. So as it is .NET, uh, as it is in fully built on top of the .NET, and we have a Microsoft community. So for long-term projects, it is suitable. So these five factors I mentioned. Based on these five factors, we can adopt the Blazor. And the technical highlights, basically, I would like to highlight, like Blazor supports standard DOM events, like on click, on change, and it also supports the custom events. So the supported events are mouse events, keyboard events, form events, focus events, and clipboard events. Like here, I mentioned all the mouse events, keyboard events. So the event types, say for example, we have a button and we have an event called onClick. So we'll mention @onClick and that particular method name, and in the C# code, we'll write the particular logic. So this is how we'll handle the events. And the validations also, it is pretty much easy. It supports the data annotations. So we'll open a tag edit form and we'll bind the model, and we'll mention on valid submit, basically. So where we'll call the data annotations to validate that particular model which we have bind. So in the validation summary tag, we'll get the validation error. So we'll have different validations, right? The required range, all other uh, data annotations will be supported by Blazor. And we have JS interruptibility. So Blazor allows calling JavaScript from C Sharp, vice versa. Like from C Sharp also, we can call the JavaScript. From JavaScript also, we can call the C Sharp method. So will Microsoft provides IJS runtime to invoke JavaScript functions from C Sharp. Say for example, in the code we can write JS runtime, invoke async, and then the method name, and we'll pass the attributes. If you want to call the C# method in JavaScript, on top of the method we need to add JS invocable attribute. So in this way we can call the JavaScript interoperability. So when it comes to third-party tools, so the other advantage I am seeing is we have a lot of components, open source components that are available in available for Blazor. So we have Mud Blazor, Radgen, Microsoft tools. These three are basically the key players which are offering very beautiful and user friendly components. So Radgen and Mud Blazor are widely used, and Microsoft is started giving the are building the the components for the Blazor. So I mentioned the links. I don't want to open them, but yeah, let me open one. So in Mud Blazor, see we have different components that are here. So all these are different components that that we can use them directly by using or by invoking that particular Mud Blazor library or the NuGet package into our project. And also, uh, yeah, before conclusion, so I would like to cover the benefits, limitations, and challenges part. So I'm comparing the Blazor server app, Blazor WebAssembly, and the Blazor hybrid. So I would like to talk about the benefits of Blazor server app. So Blazor server app basically it is fast initial load times. So it is not like WebAssembly. So it will start the application very fastly. So the initial load times is less when compared with Blazor WebAssembly, and the download size is significantly small when compared with WebAssembly, and the server side execution reducing the client resource usage. When it comes to the benefits of Blazor WebAssembly, runs directly in the browser, offline capabilities. Whereas in the Blazor server app, we don't have the offline capabilities. Every time the signaler communicates with the server, it uses the C# instead of JavaScript. So these are the major benefits of uh, WebAssembly. So when it comes to Blazor Hybrid, it offers the cross-platform support, mobile, desktop, and web. And also it offers full access to native device and capabilities, the reuse of web UI components across the platforms. So those are the main benefits of Blazor Hybrid. When it comes to the limitations, uh, as it is as Blazor server heavily depends on the signaler, we'll have a higher latency due to network ops. So for every user action, it will try to communicate to the server through signaler, so which causes higher latency due to the network ops. The scalability concerns with the many concurrent users. So if you have concurrent users, definitely the network latency will be high, and we'll have the at least I have seen these scalability concerns, and it requires constant server connection. So if the server is down, unlike WebAssembly, it won't offer the offline capability. When it comes to the limitations of Blazor WebAssembly, the larger initial download size, so it will give an uncomfortable or the unuser friendly experience to the user. So larger initial download size is one limitation that we cannot avoid, and also the restricted to browser capabilities. So as it is from the WebAssembly, advantage is offline capabilities, but somehow it will restrict to browser capabilities. So if the browser is not supporting some capability, the Blazor is also not supporting that particular capability. It's a restriction basically, and also the performance issues with the complex C# code. So if your program has a lot of complexity on the UI, on the user interaction, so it causes the performance issues. And also the limitations of Blazor Hybrid is the separate native client apps must be built and maintained for each platform. So for web, so we may have the same components can be used in different cross platforms, but we need to maintain them separately. Platform dependent components and styles. Also, giving maintainability problems and longer download and install times compared to web apps. So it is, it offers longer download and install times. The challenges I have noticed with the Blazor server app is the connection stability in poor network conditions, because it requires the constant server connection, right? So the connection stability in poor network conditions is a challenge, and server resource management for multiple users and uh, and handling temporary network interruptions will be a challenge. And Blazor WebAssembly, so initially we'll see the slow initial load times, deployment issues like file corruption, and also the compatibility issues. So when it comes to Blazor Hybrid, the managing the real-time and large-scale data is a challenge, and optimizing UI rendering for large data sets is a challenge, and offline support and data synchronization is also a challenge when we adopted Blazor Hybrid. But apart of all these things, it has reasons to adopt, and it has cases when to adopt the Blazor. So on conclusion side, Blazor unifies web, desktop, and mobile development for .NET developers. It is mainly for .NET developers. It simplifies the .NET developer life to develop the web applications, and growing the adoption and Microsoft backing fuel its moment. A key player in shaping the future of web development. So this is all about Blazor. So any questions for me?